So I'm going to start out with the word abysmal. You know, people ask me about how mining looks in the United States and what the possibility is. And the outlook is abysmal. I'll be very blunt about that. And then talk about innovations to address these challenges as we go forward. And hopefully this thing works. I guess, yeah, it is on. So we'll see. I could be going back and forth more than I usually do. But talk about some innovations in this area. Oh, I am going to be walking a lot. OK. I normally start out by putting everything in terms of energy. But, you know, really, I've been told I'm too depressing and leave everybody bummed out before I get going, you know. So I did what we have to do in modern society. I asked ChatGPT what I should start out with. And it gave me some options, you know, to come back and say, you know, I'm excited to be here, you know, and to talk about critical minerals. You know, keep my humor above the bedrock level. So talk to the geologists. And then it also came back and said, well, put it in context of being at Austin. And, you know, I'm here to talk about Longhorns, barbecue, and football. I got to see that great barbecue this week. So that, and I don't really pay attention to football. But this is less controversial than talking about Alabama and Auburn and all the other football teams out there. And then, you know, the option it gave, you know, after it personalizes the answer, which amazes me. I have a great conversation with chat. You know, and after years at RPE, you know, I'm used to working on things that are hard, expensive, and take a long time. And so now we're in critical mineral space. I'm not quite sure why this doesn't work. Ah, there we go. OK, so now to energy. The numbers are massive. And I, especially to my academic colleagues, I want to emphasize through this talk how big the numbers are. They're just huge. This is the total amount of energy used in the world as a primary source. And it comes out to about almost 200,000 terawatts of thermal energy or primary energy that's used. And it doesn't take really an advanced graduate student. Works sometimes. There we go. It's got very short range, I guess. It doesn't take really an advanced degree to tell you that the majority of this is coming from oil and gas, 82%. Nor does it take really a too much of an insight, and you don't even have to ask ChatGPT to say that number of oil and gas is still increasing. So when I made my comments yesterday about what's the impact of the administration change, you know, pretty much other than COVID, nothing has changed the advancement of our consumption of fossil fuels. You know, we might be able to say that renewables are slowing it down, but it's happening. So, plus we have to worry about all the future growth of that 150,000 terawatts. So really a big number. You know, which kind of brings me back to, let's put it in perspective and make it personal. This is, again, I want everybody to think about your individual contribution to this mess. I have to stay over there. It wants me behind the podium. When we think about fossil fuels, let's see if I put it up, see if it recognizes me. When you talk about fossil fuels, this is the amount that each of us uses in the United States in our lifetime. So you think about extractive processes, and people are like, we can't do mining because we have to extract stuff. Look at what we're already pulling out of the earth right now. The numbers are huge. Anybody in here 5'6"? I got somebody way in the back. You know, that's you standing next to it. The lump of coal that has your name on it would tower over you from this. So it's important. A lot are advocating the green transition. to get out of the use of oil and gas. Let's just get rid of it completely. In the last administration, I sat in meetings where people were advocating for an immediate ban to fossil fuels. And it's like, come on. No, that's not going to work. I got to stay on the right side. Minerals are going to be a driver for this transition if it happens. It's going to be there. And even if we don't have a transition, minerals are going to be key as we go forward. So this is something to keep in mind. I always like Daniel Yergin's quote, and it needs to be modified. At the beginning of the optimism of the energy transition, he said, we're going to move from big oil to big shovels driving our economy. And I hate to tell him he's wrong. It's going to be big oil and big shovels are going to dominate us going forward, because we need both for the foreseeable future, because all of your renewable tech is based on that. So, and this is an area that people don't understand. I always like to say, when people in the world have arithmophobia, right, fear of numbers, so all of you people who don't think about big numbers, right, you get magical thinking. People are just like, oh yeah, we can do this. It's very easy. They can draw it on a whiteboard and say that we're ready to go. So magical thinking is a challenge. Right, so let's go back and look at what is required if we do EVs. You guys have Tesla here in town. Electric cars use a lot more critical minerals than a conventional car. And everybody's like, oh, we'll just electrify all transportation. There's 3 billion cars that we would have to do by 2050 to hit net zero. And even more, there's 1 billion trucks. Trucks take 8 times the battery space to drive, as does a car. So you're talking about 11 billion cars. You multiply 200 kilograms by 11 billion, it's a big number. And if you take a look at this and say, okay, how big is it? Well, just to make the batteries for all these cars and the electric motors, it's going to take 1.6 billion tons of metal. 1.6 billion. Okay, and again, we're doing this for the environment. And what we're going to have to do is, we don't have copper falling out of the ground at 100% purity, so we have to dig up a lot of rock to get that. So just to do the cars, we're going to dig 260 billion tons of rock. 260 billion. Think about that. That's a massive number. When we put it in total amounts, anthropogenic mass on Earth, so this is everything that mankind has built on Earth, is about 1.1 trillion, so we're going to add that on top of it. Biomass is 500 billion tons of this, and our 270 is half of all the living stuff on Earth. We're going to have to mine, just for the cars. Don't forget, we got to power this with renewables. We're not going to burn all this coal to do this. So we've got to build up, we've got to dig all this stuff up. And if you look at it, the critical mineral demand of clean energy far exceeds that of our fossil fuels. So you take all those batteries and you begin to multiply all these together. It tends to be a massive, massive number. By the way, the generation capacity is, the critical minerals for generation, 5 times that of the electric vehicles. That's the generation capacity just to power the electric vehicles. Never mind everything else. So, what's wrong? Why are we worried about it? What may worry, and I would like, who here has been to a big mine? Okay, I can tell I've got some geologists around here and mining people. again, it comes back to size. And we look at this. And, and why can't we just dig more? Why don't we just go out and dig bigger holes? Like I was told when I came to DOE, oh, don't worry about critical minerals. The mining companies will respond to the market signals. And we can just have this little truck. We can put much more Tonka trucks. And we can put Tonka trucks, by the way, the truck is there, into these big holes that are miles across. Anybody know what this is? It's a copper mine, Bingham Canyon. That's a city next to it. You think about the sizes of these things. Again, we should appreciate the size. By the way, the forecast to meet copper demand, we need 40 of these in the world in the next 25 years. 40. So the easy stuff is mined. Our ecosystems are getting more fragile from this, and we notice that we're disrupting our ecosystem, so we have societal avoidance of resource extraction. This is one of those things, we don't want to dig holes in the ground. Nobody wants one of these in their neighborhood. And by the way, we offshored the industry. We just basically said, meh, we don't want to do this. We're going to send it all off to those people who don't care about their environment. Quite literally. So why does this matter? And this comes back, this is the critical mineral dependence we have on China. In case people haven't been paying attention to the news, there's a lot of issues with China right now, to include cutting all that off, right? And these are key materials for the energy transition. And if you put it into the context of what we produce in the United States, by the way, in every one of these categories, before 1990, the US was the dominant world supplier of every one of these elements before 1990, but we offshored it. So we have fractions of what we need. And what doesn't show up here is most of the gray is owned by China in different countries. So our exposure to China is unacceptable. And this attracts the attention of the Department of Defense. Coming in, we heard from Element USA that, we're getting defense money for this, for one of those little tiny ones in there, and that's germanium. And that's because it's important to have these in our advanced weapons systems. This is an F-35. It has stuff, every part of this has a critical mineral, literally, right? Every part of it. I mean, even the plastic in the canopy, right, it's not shown here, has materials in it that are on the critical mineral list. The paint has critical minerals in it. The entire system. And it's just one of the problems our defense industry has. We have aircraft, we have destroyers have these materials in them, we have aircraft carriers being held up, we have submarines being held up, they're in tanks, they're in ammunition, they're in guided rockets. And if you read, the Chinese are putting in their traceability and audit trains to keep their metals outside of our weapon systems. And we talk a lot about AI, and data centers. And this is another big one. And this is why the executive orders come out and talk about data centers and critical minerals and putting them on places. This is a low projection of what's going to go just inside the data center. This is not the power for it or anything else. This is just in the data center. You begin to look at these numbers, 450,000 tons of copper is a big number, right? Steel, I'm not worried about. Aluminum, this got real expensive because we're putting tariffs on the Canadians. I don't know why. But all of these other ones, many of them impact our total resource supply. I mean, we look at it and say 65 tons of gallium. Oh, that's not a lot. That's pretty much the annual production of gallium worldwide. It's tons. So it's said we can't change such a large deficit. You know, this is where I come back and say, all right, I just made you all depressed, right? And you come back and you say, what can we do? We can't address this. And I always like to say, we can. You know, you take a look at oil and gas, and what's happened in the last years, right? Texas is a big part of this, even though I don't think they invented it, but Texas people did this. I think they were actually TTU alumni who actually did most of the work. But if you take a look at it, in 2005, we had peak imports of oil. We were importing almost 60% of our oil. 60%. It was declared a national emergency. We were importing natural gas. We were building all types of LNG terminals to import natural gas, right? Then all of a sudden something happened. We had a technological advancement, redeployment of billions of dollars of private capital, and we're now pretty much a net exporter of petroleum products. You know, and I like to tell people that, the legislation for RPE was in 2005. You know, it came under the Bush administration, so obviously RPE did this. You know, starting the Advanced Research Projects Agency at the Department of Energy took care of that problem because our #1 mission was to reduce imports. What are we importing now? Metals. Okay, again, all the metals we mine, just to give you an idea of sizes of these. The energy minerals are on the right. We have iron on the left. That's the big one. If we get rid of that, we just go back to those EVs again, right? 2 to 10 billion tons of metals by 2050, just for the EVs. You'll notice it's a little bit bigger than we're producing annually right now, and it really comes back to say, 50 years of production in the next 25 years. Just for our cars. So, come on to the future. I'll say not much has changed in the last 2,000 years of mining. I get into a lot of trouble with it. You see, I'm an organic chemist, so I can come back and look in from the outside and say, you guys haven't done anything. It's the same thing. This guy, Pliny the Elder, right, was writing the Encyclopedia Naturalis. And one of the last chapters he wrote was metals, before he sailed into Pompeii to see what was happening with a friend during an eruption of a small volcano. The last thing he did. But he talks about this, and pretty much everything we do with mining, he talked about 2,000 years ago. It was well established. So can you keep that in mind? There's a few new things out there. Electrowinning's one. And making aluminum's another one, but most of what we do, even flotation and sizing and extractions and pyromet and hydromet, they did it 2,000 years ago. We got bigger machines. So maybe we should look at the way we look differently at the way we treat rock that we mine. And I'm going to come back to oil. Okay, in 1868, John D. Rockefeller bought this place, first Standard Oil refinery in Ohio. They had one product. They made kerosene. All right, so they'd bring oil in, throw it into a kettle, heat it up, and put an air condenser on top of it, and dribble out kerosene. All the lights just went off into the air, and the black stuff that was left over, they just dumped in the Cuyahoga River. So fraction of a percent, or a fraction of a barrel was actually put to use. 30 years later, they got a little bit more advanced. somebody figured out that we could take black oil, this residue, and scatter it on dirt roads and it stopped dusting. And then there was this funny stuff they came up with called gasoline when they put a water condenser on the system. And it was used, anybody know what the first use of it was? Solvent for drying oil paints. So they wanted to body up linseed oil and add in some solvent so it would dry faster. And then Ford looked at this. It was cheap, dirt cheap. And Ford went, whoo, this is better than kerosene or diesel. So in 1958, we have this tree. All these products now come from a barrel of oil in 1958. I've talked to oil guys now, and they're like, oh, we can't even come up with a tree. It's going to look like a pine tree, and you can't tell where anything is. So when I talk about let's treat rock like a refinery, people always say, we have no use for all this stuff that's in the mine. There's no market for it. We just can't deal with all this silicates and aluminas and everything else. It should be noted that on this tree, none of it existed before an engineer figured out how to isolate it and found a use for it. All refineries now can only survive if they use all the material. So maybe you should be interested in trash. We're going to talk about this refining of materials. Anybody know where the trash goes here in Austin? Or your home? Scary. U.S. municipal solid waste, 300 million tons per year, is dumped in a landfill. It contains 30 million tons of metal. Just think about that. We're worried about metal, and we're throwing out 30 million tons. There's 1 billion tons of metal sitting in the ground, right? And we're going to have another billion by 2050. It's worth $1 trillion or so. So when I hear Element USA talking about this, it kind of comes back and says we need to be able to fractionate it. So we take a look at e-waste, right? Where does your computer go? Everybody's like, oh, I'll bring it back to Best Buy and it gets recycled. No, it doesn't. It gets thrown on a heap someplace. Very little recycling of electronic waste. The concentrations of these critical minerals in e-waste exceed what we mine in many places. And we throw it out. Because everybody's like, it's not worth dealing with it just to get the tin out of it. But if you fractionate it, you can get everything. So I also challenge everybody here to say, why don't we go out and find some more reserves of these materials? Because I just talked about recycling what we have. And recycling is not going to keep up with it. We have this demand that's out there. And how do we address this demand? So if you kind of look at this, the supply gap right now is $12 trillion of what the demand for minerals versus where we know it is. Why aren't you guys looking at that? This actually could be $30 trillion worth of missing stuff if we keep to that net zero. Why don't we look at precision mining? And again, I had to go to ChatGPT, and I just asked ChatGPT, what's your thoughts about the mining of critical mineral, precision mining of critical minerals? And it came back, and it actually had pretty intelligent discussion with me. It really talks about, we're going to do this, and it comes back in and really just says, rather than moving all the surrounding materials, we'll do this. And it's geospatial mapping, AI-driven core characterization, autonomous drilling and cutting systems. This is all stuff that's in your oil and gas department here on campus. And I said, what would this look like? I mean, come on, give me a graphic. Don't give me a bunch of sentences. And this is what ChatGPT thinks this looks like. I didn't ask Google. I probably should have asked Gemini what it thought it looked like. It would give me a more depressing look. Gemini suffers from severe depression, in case you guys don't know that. But it kind of comes across, and it tells us all the issues, right? You know, the handles that you need to do, the advantages. So if you need a research idea, just ask AI and put in the DOE requirements. People should take a hike to tailings piles. You know, we hear about Element USA. You know, what's in these? What's in this? We throw out all this rock. For copper, it's calcium, magnesium, iron, alumina, and silica. It's all stuff that we mine somewhere else, literally. You know, down the street, I ran into this at Imerys Industrial Minerals Company, where the guys down the street were mining what we thought was waste. And it was like, we're throwing it over the hill and they're digging it up and selling it. Something's wrong with this picture. So how do we use it all? You know, the volumes, again, are just massive. You know, there's 6 cubic miles or cubic kilometers of waste in our tailings piles today. And this is actually getting kind of old. It's probably approaching 10 if you throw it all together. You know, and we look at, if we're going to get this billion tons of copper we need, we're going to mine 800 billion tons of rock just to get the copper. We're going to throw it all out. Right? Copper is 46%. The fastest growing mineral on Earth is copper. So, in the future, we have to deploy fast. And the one thing I want to tell everybody is, how do we do this faster and faster? Because it's not going to happen in my lifetime, probably. But there's some people in the area that I think hope that within our lifetime we can do this. So, you know, hard tech is hard. Everybody will say, oh, it takes too long, it does this, right? You know, and again, you know, you got to go to ChatGPT, hit the easy button and say, oh, what do we do? And so I asked ChatGPT yesterday while I was sitting here about one of the companies I'm working with, Phoenix Tailings. You know, this is a company that I'm an advisor for. And they're a company that's coming up with a novel new way to do rare earth element metallization and extractions. Did a great, so it actually came through and did a nice job going through, right? And this contrasts with traditional methods that have harmful chemicals. So it picked up on their technology. And you come back and say, how can we do this fast? It can be. Phoenix Tailings was founded in 2019. Right? They got their first venture investment, and actually their first award funding was from me at RPE. It was early on. And I gave them a challenge, which was put a kilogram of neodymium in my hand. And that's me holding the kilogram of neodymium they produced in their first year. Right? 2023, they did piloting in Burlington, Massachusetts, fully permitted to do this. 2025, this year, right now they're opening their first full-scale production plant in Exeter, Massachusetts. And their promise, no emissions. So this is radical new tech. And it took 6 years. 6 years. That's almost the lifetime of a graduate student. You know? So you can do things fast. And where are they going now? You know, this is the part where, you know, I talked with the CEO of the company and founder, and he's like, I need this. And they have a technology that can do that. And so with that, I want to thank everybody. And if there's time for questions, I can answer questions.